Hey, good morning, guys. Welcome back to Algebra 2B. We've only got 3 weeks left, which is kind of scary if you're a senior. So I've kind of outlined the rest of the year in the top left corner of this page. I hope you guys are staying safe and taking all necessary precautions to avoid getting this illness. So as always, if you need anything, you can always feel free to email me. I'll do my best to get back to you as soon as possible. Our first question today, I just wanted to try some paper folding. So if a piece of paper is 0.1 millimeters thick, if I fold it in half, how thick is that paper now? So you can try this if you really want to. And if I fold this paper in half, if I fold that in half, then I end up with that's the wrong application. There we go. 0.2 millimeters thick. Okay, so now I've got 2 layers of paper. Well, what if I fold that in half again? How thick would that be? Well, now if I fold that in half, then I've got 4 layers of paper, which makes it 0.4 millimeters thick. Well, what if I fold it in half again? Well, let's see. 1 fold is 0.2 millimeters. 2 folds is 0.4 millimeters. 3 folds would be 0.8 millimeters. 4 would be not 0.16. 4 would be 1.6. 5 would be 3.2 millimeters. 6 would be 6.4 millimeters. And we're going to come back to this idea here of 15. But what's going on here with these numbers? Well, I keep multiplying them by 2. It keeps getting twice as thick, that piece of paper. And we're going to be talking about geometric sequences all week. And a geometric sequence is a sequence where each number is multiplied by the same common ratio. I keep multiplying by the same number each time to get the next number. So let's look at these first 4 examples. So number 1, what would I multiply to go from 1 to 1? Well, that would be multiplying by 1. Okay, well, what if I go from 1 to 2? Well, there I'm multiplying by 2. Here I'm multiplying by 1.5 and 1.67 and 1.6. So I'm not multiplying by the same thing every time. These are really different numbers. So this is not geometric. Okay, let's try number 2. So what do I multiply 1 by to get 4? So 1 times what number gets me 4? Well, 1 times 4 gets me 4. And 4 times what gets me 16? Well, 4 times 4 gets me 16. 16 times 4 gets me 64. 64 times 4 gets me 256. And if you're ever not sure, what you can do is you can take 256 divided by 64, 64 over 16. You can always divide by the number before it and see if you get the same number, and you will. So my common ratio here, that number I keep multiplying by, is 4. So yes, and my ratio is 4. All right, let's try number 3. Number 3 is kind of tricky. So 1 times what is 1? Well, 1 times 1 is 1. Times what gets me 1? Well, 1 times 1 is 1. times 1 is 1, times 1 is 1. So this is geometric, but what's my common ratio? What am I multiplying by every time? My ratio is 1. And number 4, this is where this approach really comes in handy. So maybe you're not sure what you're multiplying by there. But we can always take 5 divided by 25 and see if that's the same as 25 over 125, and see if that's the same as 1 over 5, and see if that's the same as 0.2 over 1. So we're seeing, are all these the same? I want to know that. And if I type those into my calculator, those are the same. And that common ratio is 1/5, or 0.2. So yes, and my ratio is 0.2 or 1/5. So you could put that as a decimal or fraction, either way. All right, so number 5, what's happening? 300 to 100, what am I doing? How do I go from 300 to 100? Well, I could divide by 3. And let's see, if I divide 100 by 3, do I get 33.3 repeating? Okay, I typed that in my calculator, and it seems I would. And if I divide that by 3, then I do end up with 11.1. So is this geometric? Well, yeah, it's geometric, and my ratio is I'm dividing by 3. And then try the same thing here with number 5. You can try that dividing ratio and just see if you get the same thing every time. Just divide the number by the number before it and see if you get the same number. And of course you do, and the ratio is 1.5. So that's how we identify a geometric sequence, but here we're going to look at our equation for a geometric sequence. So my first term is going to be 3, and my common ratio, what I'm multiplying by, is 2. So this is my first term, that's 3, and how many times did I multiply by 2? That's 0 times. For my second term, I took 3 and I multiplied by 2 one time. Here I took 3 times 2 is 6, times 2 is 12. Okay, for the fourth term, I took 3, so times 2, times 2, times 2, so times 2, times 2, times 2. And how many times did I have to multiply by 2 to get to my fifth term? So 1, 2, 3. I gotta multiply by 2 again. So 4 times. 3 times 2 times 2 times 2 times 2. And to get to my sixth term, multiply by my common ratio of 2 again. I got 3 times 2 times 2 times 2 times 2 times 2. All right, so let's see what's happening here. My first term, I'm going to simplify all of these. I'm going to simplify all of these. This was 3 times 2 to the 0. Okay. This was 3 times 2 to the first. I had 1, 2 there. My third term, I had 3 times 2 times 2, but how can I rewrite 2 times 2? What's another way of expressing 2 times 2? Well, I could write that as 2 squared. Okay, what about 2 times 2 times 2? I could write that as 3 times 2, and I have 3 of them, so 2 cubed. Okay, what about 2 times 2 times 2 times 2? Well, it's 3 times 2 to the 4th. And our very last one here, how many 2's do I have here? I've got 5, so 3 times 2 to the 5th. And what do you notice about these exponents, these powers, as they relate to the term? The first term has 0, second term is 1, third term is 2, fourth term is 3, fifth term is a power of 4, and the sixth term is a power of 5. Well, the exponent's just 1 less than the term. So to find the nth term, it would be 3 times 2 to the, and again, it's 1 less, so 6 minus 1 is 5, 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1, so n minus 1. So the nth term, a sub n, can be written as, so a sub n equals my first term times the ratio to the n minus 1. So let's get some practice with that. My nth term is going to be my first term, 7, times my common ratio of 13 to the n minus 1. So we're really just going to substitute in for our first term and common ratio here. Everything else is always going to stay the same. Let's try number 2. That's not what I wanted. The nth term would be my first term of negative 2 times my common ratio of 5 to the n minus 1. All right, I'm going to do 3 and 4, and then I'll have you guys pause the video and try 5 and 6. So my nth term is, what's my first term? 8, and the common ratio is 9 to the n minus 1. And number 4 here, what's my first term? 15, and my common ratio is negative 1 to the n minus 1. So why don't you guys pause the video and try 5 and 6 for me. So you got to determine what is your common ratio. So 5 times what gets me 15? 5 times 3. 15 times 3 gets me 45. Times 3 gets me 135. So first term is 5. My ratio is 3. So nth term is what? Well, that would be 5 times 3 to the n minus 1. And for number 6, what's my first term here? First number you see is 11. And what's my ratio? What am I multiplying by every time? I keep multiplying by 3. So my equation is first term times common ratio to